This is my entry into Element 14's Hack Like Heck competition to build a portable gaming device. In Ben and Felix's video, they built a system around a Raspberry Pi. They built the electronics first, and then built the case around it later on. But for my build, I'm going to approach it slightly differently because I've got an idea for a case design that I want to try. So I'm going to start with the case design and then build the electronics to fit that. Let me show you what I mean. So I want to try to build something similar to the Nintendo Switch. I think it'll make for a good Raspberry Pi portable. We can use a nice big display, and we should be able to use the Joy-Cons for our controller. So I was thinking I could have the Raspberry Pi on the right. I've got a display here that's roughly the same size as the one on the Switch, and it has a little driver board that will go in the middle, and then there should be room for the battery on the left. So kind of something like that. Yeah, I think that can work. So that's the basic concept. Now I need to start drawing some of these pieces in the computer. I'm going to start by sketching the screen because we're going to need to base the rest of the case around it. I've already taken some measurements, so I can just type them in here, and then all I need to do is extrude it out to the right depth. But the display itself isn't centered. There's a frame around the outside and it isn't symmetrical. So we need to account for that. If I draw a rectangle and type in the dimensions, then it will give us the offset frame, and I can just make a small extrude cut, and then we've got a new face that we can use to anchor the rest of the case around. And here we are a bit further on with the design now. Got most of the basic shapes sketched out. All of the curves are looking pretty nice. And if I hide the front bezel, you can see the LCD is mounted upside down now. And that's so I can fit some speakers down at the bottom. Inside the case, there's plenty of room to work with. I've drawn up the rest of the components, and I've got the battery, the HDMI board, and the Raspberry Pi. But because my screen's quite thick, I think I'm going to have to remove most of these ports. If I bring it back in, you can see it definitely clashes there. If I turn on the section analysis and have a look from the side, just hide that HDMI board, yeah, you can see almost all of the ports clash, and we're going to have to remove those. But before we do that, I want to do some testing first. In this test, I'm checking the power draw of the system. Ideally, the total current will be less than 1 amp, and that way I can use an Adafruit power boost to charge my battery and also supply 5 volts for the portable. I've got the screen on the left channel and the Pi on the right, and it seems like the screen is pulling a lot more current, around about 800 milliamps. I didn't expect it to be that high. The Raspberry Pi value seems to bounce around with the processor load, so I don't expect that reading to be all that accurate. But even so, it looks like less than half of the current of the screen. So I definitely want to take a closer look at this driver board and try and see what's going on. Okay, so here we are close up on our HDMI board. We've got 2 linear voltage regulators here, and they're both marked AMS 1117s. This one is 1.8 volts and this one is 3.3. Up here is probably the step up for the backlight, so I think I'll leave that area alone, but I'll be interested to see how much current these 1.8 and 3.3 lines are using. Now, power is important for a portable because we only have a finite battery capacity, and in our case it's going to be relatively small, so we need to be as efficient as possible. We already mentioned that our screen is using linear regulators, and they can be quite inefficient. A better solution is a switching regulator like this, but they come on these fairly large modules, and I'm only going to have enough room for one of these in my case design. So I need to decide which regulator to swap out. And I can do that by working out the power that each one's wasting. So the 1.8 volt regulator, its output current is about 100 milliamps. And that means its output power is about 200 milliwatts. But its input power is about 500 milliwatts. So it's wasting about 300 milliwatts of power there. For the 3.3 volt regulator, it's outputting 120 milliamps, and that's an output power of about 400 milliwatts. And its input power is about 600 milliwatts, so it's wasting only about 200 milliwatts. So it might make sense to replace the least efficient regulator, and that's the 1.8 volt line. But there's actually a better solution. You see, if we put this switching module on the 3 volt line, then we'll save some power there straight away. But we can also use the output of this to drive the input of our 1.8 volt regulator and save some power there too. And that's because of the way linear regulators work. So as standard, our input voltage is 5 volts, and that gets dropped down to 1.8 volts. So a voltage drop of 3.2 volts. And this is proportional to the power that's wasted in the regulator. So if instead of 5 we feed it 3.3 volts, then it only needs to drop 1.5 volts to get down to our output voltage. And that's less than half that it was before. So less than half of the power wastage. Our efficiency is going to double there effectively for free. And it actually makes a big difference to our total screen current consumption. Whereas before it was about 800 milliamps at 5 volts, afterwards it's down to about 400 milliamps. And the reason that's important is because it brings the system draw down below 1 amp. So that means I can use an Adafruit power boost to charge the battery and step up to 5 volts. And also it's going to give us a bit of an increase in battery life. So this is a little bit further on now, and I'm going to show you how I strip down the Pi and wire the HDMI connections. We're going to start by removing the pin header. That's that black section there, and the pins as well. It's easiest to start off by trying to lever up this black plastic, and then you can remove the pins individually. If you try and remove the whole thing at once, then it becomes a lot more difficult. So I'm going to take a sharp tool and just try and lever this black plastic up. Okay, there we go. I'll spare you the boring details of this part. Basically I just cut off all of the metal shielding and attacked it with some pliers, just peeled it off, and that meant I could clean the rest up with a soldering iron. And eventually I had a completely clean Raspberry Pi with no ports at all. To replace the HDMI connection, I'm going to use a flat flex cable. It needs a half twist to ensure that the pins line up. And this is a 20 pin version and HDMI is 19 pins, so one of the pins is just going to hang over the edge, but hopefully it should work. Now, the pins are already nice and clean. This is a brand new connector, so shouldn't have any trouble. Okay, I'm just going to run a bead of solder down there, see how we go. Try and give you a close up. Time to test it, I guess. I've got the flat flex cable there. You can see the twist or the half turn. On this end I did break the latch, so I've just put some tape in there so it fits the connector. I'll probably go back and replace it, but we'll just test it anyway. So there we go, powered on. That's a good sign. We've got some activity. Oh, there we go. Oh, is that a cursor? Just there? Yeah, I think so. Ah, brilliant. Okay, so it works. Here are the almost final guts of the unit. I'll give you a quick tour now. So, I have the Raspberry Pi here on the right, the HDMI board in the middle, a battery there. Down here is an amplifier for the speakers. So we've got two speakers there. That's the external Bluetooth. Up here is the wireless keyboard dongle. I have an Arduino here, and that's controlling the power switch, and also I've got a max 17043 fuel gauge just to keep an eye on the battery status, the charge percentage, etc. Up here is the power circuitry, and I'll flip it over so we can have a better look. Okay, so you can see where I've removed the 3.3 volt regulator there, and that's the switching regulator that's replacing it. Just there's the wire to feed into our 1.8 volt reg there. I've replaced the clock crystal there with a slimmer unit there just to get the thickness down. There's our fuel gauge circuit, and that's powered off the battery board, so that's an Adafruit power boost, and that's keeping the battery charged and stepping it up to 5 volts. That's about it. I'm just about to install it in the case, so the next time you see it, it will be almost ready to go. Nintendo Switch, Raspberry Pi switch. So this is the home page that or home screen. It's based on a emulation station skin by Little Bud. I've just changed some of the icons and formatted it a little bit to fit my screen. Up here in the corner, this information display is run from some Python scripts. So I have one that grabs the time, the network or the Wi-Fi status, and also the battery percentage. Right, so I guess I should show you the Joy-Cons. Got a pair here. I just start them up, try and get them synced. There we go. And I'll leave you now with a montage of the game footage while I sum up the project. Overall, I'm quite pleased with it. I'm happy I was able to keep the dimensions the same as the original Switch. But I did cheat a little bit. My case is 1mm deeper actually, but I did like the theme and the overlays that I made. That was a lot of fun to learn. If I had more time to work on it, then I would fix a few things here and there. The 3D print is a bit rough in some places. It really needs printing again, but I didn't have enough time. The power and volume buttons on the top could also be made to fit a bit better. And I'd like to install a pair of switches to detect when the Joy-Cons are attached and detached. I wrote some code for this and tested it out. I had it all working. I ordered some new switches and they were the perfect size. I'd modelled them up in CAD, but when I went to install them at the weekend, I must have just lost the bag somewhere, which is a shame because the code worked great. I had a little animation that played and it looked just like the real Switch. Oh well. I'd also like to find a slimmer screen. The one I use takes up a lot of room, and it'd be nice to have a larger battery instead. Maybe finding a screen that could hook up to the GPIO like Ben and Felix did. I think that might save some space in the case. Also, I'd like to be able to physically connect the Joy-Cons. The Bluetooth works okay, but it takes a couple of seconds to pair, and for some reason the lights don't go out, they just keep blinking. But that's a minor issue really. So in conclusion, this was definitely a fun little project. Even though it didn't turn out quite as polished as I'd like, I'm glad I took part in this contest and look forward to seeing the other entries.